Prove that the limit as x tends to infinity of 1 over x squared is equal to 0. Okay, so we're working with a limit at infinity. So our proof should probably follow the general format of, suppose we have some epsilon greater than 0. Okay. We need some cutoff value, capital N, so that if we assume x is greater in value than this n, the difference between our function and its proposed limit 0 is less than epsilon. Okay? So what we need to do is find a value n based on whatever possible epsilon somebody might give me and show that we get this implication. Okay. So we need n based on epsilon. Well, usually the n is based on epsilon. For weird exceptional cases like constant functions, you don't really need to do that too much. Okay, but, all right, so we need x greater than n implies, what is it? 1 over x squared minus 0 in absolute value is less than epsilon. Well, you know what we can do? We can simplify that. Okay, so this is our goal. But, well, 1 is already positive. X squared is never negative. So really, we can rewrite it like this. And you know what? We could rearrange it. And we're just trying to get a feel for how the epsilon and the possible values of x that satisfy this relationship are related. Okay, so 1 over epsilon, that's going to be fine because epsilon is positive. Okay, and since epsilon is positive, 1 over epsilon is also going to be positive. So we can take a square root for that. Okay, so it seems like this would be a good choice for our n value. Okay. As long as we can make sure the n's are bigger than this amount, we'll be all set. But just because we've worked backwards to get an n does not always guarantee that this will work. So we have to write up a nice, neat, proper proof. Okay, so here we go. Here's our actual answer, not our behind-the-scenes rough work. Let epsilon be greater than 0, be an arbitrary positive real number, we claim that n being equal to, you can say square root of 1 over epsilon, or I'm just going to say 1 over square root of epsilon. They're both the same thing. So we claim that this n will satisfy the definition. Okay, so that's our claim. Now we've got to prove it. So what are we going to do? Well, we've got to show off our work. Suppose x is greater than this n. Okay. So now what I want to do is take just this piece of information and use it to show the result that we're after. And that's it. Assuming x is greater than n, nothing else, you must show that you get this conclusion. All right, so what could we do? Well, then, this implies, if I square both sides, okay, x squared is greater than 1 over epsilon, 1 over root epsilon squared. Now, you should be careful with something like this, okay, because I could have an x of 1 that is greater than negative 2, but if I square both sides, I get 1 is greater than 4. Okay, so you got to be careful with something like this. Okay. And we'll make a little side comment off to the side. The inequality sign doesn't change since both x, well, let's say since both epsilon and thus 1 over root epsilon and the x is greater than it are positive. Okay? Because if I square negative numbers, the sign will actually flip around. And if one of these is positive and the other one's negative and I square, you can get absolute chaos. Okay, so we make that little comment off to the side. Okay, so that implies x squared is greater than that. But, of course, that's 1 over epsilon. Okay, so we've got x squared is greater than 1 over epsilon. We can multiply by epsilon on both sides, just doing it very slowly to be careful. Again, epsilon is positive, so the inequality sign here doesn't change. Okay, and we'll divide by x squared, which is positive, so not only can we divide it, but it also doesn't change the sign. Right? If it was something like minus 2 epsilon is greater than 1, okay, you can't say epsilon is greater than 1 over negative 2. The sign would actually flip around. Okay, so you have to watch out for things like that. But we're getting closer. Okay. Well, what could we say? So we need to bring the absolute values in here, but of course, we could say squares are never negative. So it's okay to just add in the absolute values here. And then epsilon is greater than, we'll just add in the minus 0. And that's all we needed to show. So we put the pretentious little box that says, we finished what we set out to do. Okay? So we made a claim about an n, and then we started by assuming the x satisfied that condition. We had to be a little careful as we did things, but we transformed this statement, comparing x and n, into the desired statement showing that those same values of x must satisfy this relationship. 1 over x squared minus 0 in absolute value must be less than epsilon.